Hey everyone, it's Actuary Dude here again, and now we're going to look at some longer exam question. So, the force of interest, delta t, is a function of time at any time t, measured in years, is given by all of this. So part I is determine the discount factor Vt that applies to time t for all t greater than 0. And that sounds awful, so let's make it easier. So, what is the formula for Vt? Well, that is equal to e to the power of the negative integral with 0 to t of the function delta, we'll call it delta s rather than t because we've got the variable up there, ds. And so now essentially we've just got to sub each of these in to here, almost. So there's going to be, I guess our answer is going to look a little like this, being equal to, we'll have a thing like that, and whatever our answers are, 3 lines, and then it'll have our time constraints. For 0 is less than or equal to t, which is less than or equal to 4. And let's start with that bit. So let's first find out for this part. So we're going to have e to the negative integral between 0 and t of 0.08 ds. So what is the integral of that? Well, the integral of that is 0.08 s, and then we'll just put that between the two times of 0 to t, which then becomes 0.08 t less 0.08 times 0, which is nothing. So this is really what it is. So we can write down it as e to the negative 0.08 t. Alright, so that's good. We've done the first bit, and I can just tick that off there. Now let's look at, and I'm going to give myself some more space, and you'll see why. For 4 is less than t, and less than or equal to 9. So we're just going off there. Alright, so what we need to do is, we're going to do the same thing that we've done here, but we've also got to multiply it by e to the power of the integral between 4 and 0, because we've got to take the discount factor for all of that time as well, of that first function, 0.08 ds, and then we're going to multiply it by e to the negative integral between 4 and then t of our new delta s, which will be 0.12 minus 0.01 s and ds. Sorry, I don't know how that came about. So I'll just fix that. ds. Okay, so if we know that the integral of this bit is just 0.08 t, then all we have to do, and this is v to the 4 that we're trying to find, this bit over here, all we have to do is just sub 4 into that t, or over here. So it's just going to become e to the negative 0.32. And then we'll multiply that by this bit over here. So what's this? What is the integral of all of this? It is 0.12 to the times s minus 0.01 s squared divided by 2. Put it within the constraints, t and 4. And now let's just find out what that'll become. So we've still got here e to the negative 0.32 multiplied by. So now it's going to be 0.12 t minus, this becomes 0.005 t squared, and that whole thing is going to be minus 0.12 times 4, which is 0.48, and then minus this negative, which is then a plus, so that's 0.005 times 16, which actually happens to be 0.08 when you use a calculator. And so how does that look any better? Well, let's work this out. So we've got, and that's e to the power of all of that, e to the negative, all of that by the way. So let's have a quick look at what this would be when we simplify everything. Let's start, we've got an e over here and we have negative 0.32. We can just add the indices together. So we're going to have minus 0.12 t plus 0.005 t squared plus 0.48 minus 0.08. So this bit over here becomes 0.4, minus this 0.32, because they can all work together, becomes 0.08. So it's then going to be e to the negative 0.12t plus 0.05 t squared plus 0.08. And that's our answer for the next time constraint. So let's remember that. I'll just write it in here. Becomes e to the negative 0.12t plus 0.005 t squared and then plus 0.08. Sorry how bad that looks. And okay, now for the last time constraint. So I'll just move that, and it says for t being greater than 9. So same thing, we're just going to find the integral of this, and we're going to multiply it by v to the 9. So what is v to the 9? Well, all we're doing is subbing 9 into this whole bit over here. So it's going to be e to the negative, that is what is 12 times 9 becomes 1.08, because it's 108. So I'll write that down. 1.08 plus, what is 0.05 t squared? So that's going to be 0.05005 times 81, because that's 9 squared, plus 0.08. Alright, so let's just use Excel to find out what this is exactly. So it won't be a moment. And okay, so we've got, that was equal 0.12 times 9, and we have equal 0.005 times 81, and then we've also got 0.08. And so the answer was, this was a negative, so I'll just say, start like here, add this bit, minus this bit, and we get negative 0.595. Okay? Negative 0.595, and that's e to that. Okay? So we've got that bit, so I'm now just going to move all of this up here, and we can look at the next, that final time constraint. E to the negative 0.595 times, it's going to be e to the negative integral of, what is it? 0.05 ds between t and starting at 9. So we don't need to write down like to infinity or anything like that. Okay, so we've got this. What is the integral of this bit? So 0.05 s in between t and 9. So that's then just going to be 0.05 t minus, what's 9 times all this? 0.45. And that's e to the negative all of that. And we've also got negative 0.595 multiply, so these get added together. And so now what is e to the negative 0.05 t minus 0.595 plus 0.45? Don't know if that's off the top of my head, so that's going to be minus that bit, so minus 0.595 equals that, plus 0.45 is negative 0.145. And so here it is, 0.145. So let's just copy that down. It becomes e to the negative 0.05 t minus 0.145. And this is our answer, essentially. This bit over here could be written out a bit neater to that first bit. And this part of the question is actually worth 5 marks. So I guess you can see why it's taken a bit of time to do. So I'll put in the next video the other 2 parts, which I think are actually quite a bit quicker.